Good morning. This is a test review for MAT081. I'll go through 15 practice questions, multiple choice, to get you prepared for the upcoming test that we'll be taking on Wednesday. I handed this out in class last Wednesday, and you can also access it through Canvas. Download it, take a look at it, practice, know these 15 questions forwards and backwards, inside and out. If you have difficulties with any of them, watch how I work them here, and then find similar problems in the homework. There's also the online review in MAT-AS that should be completed, as well as the 45 question review packet that is available in MAT-AS. There are solution videos for those. So please take a look at all of those resources so that you're well prepared for the upcoming exam. Okay, so also remember, while you're here watching this video, it's real easy to go ahead and click on this subscribe button in YouTube right below. And then that way you will have access to all the videos as they become available. And that's the purpose for me doing that. This week, before spring break, if you do it, I will give you some extra credit points, as I mentioned in class. So after this, though, the benefit becomes less and less. So please subscribe this week, get your extra credit points. It'll help you with the exam, and then you'll always be getting notifications when videos are available. Okay, so let's go ahead and start into this practice test. Okay, here's our first question, and as we usually like to do, we should read the question backwards. So we see the question mark here, this is where the question is, and the question word, what, we're looking for a fraction, so that's what our answer is. We see some fractions down here. But remember, there's different types of fractions. So this is a fraction of all of her credits. This is telling us we're looking for a whole. And the math and science credits, this is the part over whole. Okay, so our fraction will be the part over the whole. Now we've got that information before we even got into the information I was given, but now we know that Erin is taking 13 credits this semester. She's taking 13, that is the whole. That's everything she's taking. 8 of the credits are math, so this is the part. The math and science comprise 8. Now we've identified our whole and our part. We put the part on top. We put the whole on the bottom. We reduce if we can, but we can't, and we see our answer right here at C. And it's just like that. If we reduce, we would do that, but that's it, part over whole. Okay, so that's the first question. See if I can get to the second question. Okay, here's the second question. Now those of you, I passed out this in class, the shading wasn't really shaded, so hopefully this looks better for you. So in this case, we want to determine the fraction. So again, that represents the shaded area where the unit is 2 rectangles. So the whole is all of this. So while it looks like two pieces, this is maybe, look at them as being joined. So this is a whole thing that's been divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pieces. So there's 10 divisions. The whole has been cut into 10 pieces. And of that, the shaded pieces, again, a part over whole, are 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 10. Part over whole. And this one does reduce. 2 goes into both of these. So we divide both the top and the bottom by 2 to reduce the fraction. 8 divided by 2 is 4. 10 divided by 2 is 5. And we see our answer right here. I forgot to put the fractions in. This when changing it to inverse, it dropped off the fraction lines, but we'll just fill those in just in case you were wondering what was going on there. That's that. Okay, so that's question number 2. Put that away for now. Come over and get down to number 3. Which of the following is true? And again, we're missing our fraction bar, so I'll fill those in real quickly. These are all fractions. And the way we're going to do this is comparison. So when we see a symbol like this, this is saying this side is bigger and this side is the smaller side. When we see it going the other direction, it means the bigger side's over here and the smaller side is over here. So we're looking at these. So we're comparing two fractions, and let's see how can we do that. Now you could take each of these fractions, turn them to decimals, and then compare the decimals if you'd like to do it that way. But if you'll notice, pairs of them have either the same bottom, these two, or they have the same tops, the same numerators. Okay, so this is really a principle that was brought out in the one of the modules. If they have the same bottom, that means that they are fractions that are of the same size. So if I take this circle and cut it into 3 equal pieces, each of those pieces is equal in size. So each of these 8s is the same size. Well, I've got 2 of them here, 3 of them here, but notice something here. Some of you have missed this. There is a negative here. Negatives are always smaller than positive numbers. If we look at a number line, here's 0, here's a positive value, here's a negative value, and we define larger or bigger to be to the right. So anything to the right is going to be bigger. Okay, so that means 2 over 8 is bigger, but that's not what the symbol's saying, so this is not correct. Now we come to this next one. So while we're at it, let's look at the 11. 11, these are same sizes. So we've got 6 of these and 7 of these that are the same size. So which is more? Well, 6 is less than 7. 7 is bigger. This side is the bigger side because, again, they're all the same size pieces, but over here we have 7, which is more than 6. So this is not correct because the inequality should be going this direction to make it correct. Okay. Now let's look at what happens when the tops are the same, the numerator is the same. So it's saying we have 2 pieces. In both cases, we've got 2 pieces of something. So what we have to look at is which of the pieces are bigger. Well, your gut instinct might say that 9ths are bigger because 9 is bigger than 7, but what does the 9 mean? It means we took something that was a whole and we divided it into 9 pieces. The 7 means that we took that same thing, that same size, but we divided it into 7 pieces. We only shared it with 7 people, so our pieces are going to be bigger. So while we have two pieces and two pieces, these are the bigger pieces here. This is bigger, and the symbol is going in the right direction. This is the bigger side, it's supposed to be, and it is. So this is the one we want. While we're on it, we'll look at this. Sizes are the same, so there's three pieces of each. But in this case, fourths are the bigger side, fourths are the bigger pieces, eighths are smaller, and this symbol is going the wrong way. So that's what makes this incorrect. Okay? So it should be B. But it's just reasoning through the fraction problems. Remember, you can always speed up, slow down, wherever you're having difficulties. You can also go back and watch something again if you missed something. And you can pause to take a look at what's going on. Okay, for this one, determine the number that is represented by the point plotted below. So we see this, first of all, since it's in the negative side, it maybe kind of feels backwards. What we want to do though, see this is 6.9, this is 7.1, so we want to characterize this as 7.0. So that each one of these is not a tenth, but notice we go all the way over here, that's when we get to a tenth. So what is this space here? Well, that must be, since we're getting negative, we're getting more negative, 7.01. These are hundredths. This would be negative 7.02, 03, 04, 05, 06, 07. This should be 7.07. Again, negative 08, 09, 10. So again, if you want to put a 0 on here, so these are hundredths, not tenths. So that means we look down here, here we go. And again, if you counted it from here to here, you could count there was 7 ticks in between, so either B or C looks good, but C doesn't match up because this would have to be 7, like 7.8 or maybe 8. If this was 8, that would work. So if we were going from negative 7 to 8, but we're not. So this is what we got. Okay. And again, remember there's all the resources in MAT081 to review on any of these that don't quite seem to fit. I'm kind of doing a quick review, and you may need to go back into the lessons and look a little deeper. So now we're asked to write something in decimal form. So wherever you see the and, that's where the decimal is going to be. So 2 is the whole part. We've got 2. And sometimes it's better to go from the written word to a fraction and then turn that fraction into a decimal. 7 hundredths. What is 7 hundredths? That is 7. Oops, not 700. Sorry, I made the same mistake. It's 7 hundredths. And again, don't notice there's also the option of using your calculators. So what is 7 hundredths? We can simply take 7 divided by 100. See, that's going to be 0.07. So 0.7, so it should be 2.07, and that's going to get us to C. So get the spacing. So here's a 700, but it's got the th on the end, so that means it's a decimal. This is not correct. That's 7/10 actually. So the following zeros on decimals have no meaning. This is 2,700, so that's not correct. And this is 2 7/1000ths, not hundredths. Okay, so watch the decimal places and use your calculator when needed. Put this down here. We're doing pretty good. We're on 5 so far. We'll go to 6. Okay, the population of Deschutes County in 2016 was approximately 1.82 million. Which of the following represents the population as a place value number? So how do we write 1.2 million as a number? We can kind of see which one of these is going to work. Well, what we could do is just take 1.82 in our calculator and then multiply it by a million. A million is one with 3 zeros, 6 zeros. Okay, so let's just do that. 1.82 1.82 times 1 with 1, 2, 3, 1, 2, 3 equals 1,820,000. So we'll see that that's option D. Okay, so place value. So that point is really just saying there's going to be some zeros behind it, and we're good to go. Six, just keep on rolling. Here's 7. Again, when I convert it over, it loses the fractions, so I'll put those in. 1/4, 3/5. And also, if you have a TI, what is it, the 30, one of the versions of the 30s, it's really good at doing fractions, so you could actually, several of you, I showed you how to use it. You could just go ahead and use it. But I don't have one on my screen, so we're just going to keep going with doing these by hand. So, what fraction of his tuition is paid with scholarships and loans? So again, coming back, seeing what the question is, what's the fraction that's paid with both scholarships and loans? So if we know how much is scholarships and we know how much is loans, this is a problem where we're just going to add them together. So we are told that 1/4 of the tuition is with scholarships, 3/5 is with loans. So that's a problem where we take 1/4 plus 3/5. And when we're adding fractions, we have to have common denominator because we need the same size pieces. We cannot add things that are not the same. So how do we get same size pieces? Well, we look for the common denominator, so this is kind of what we were doing in last series of lessons. What do both 4 and 5 go into? What is the least common multiple is what we're looking for. So 4 and 5, well, 4 times 5 is 20, and there's really no number that's less than that because 5 is prime. So we want to make both of these into 20ths. So the way we make 4 into 20ths is we multiply by 5. But if we multiply the bottom by 5, we have to multiply the top by 5. And the reason is 5 over 5 is 1. When you multiply by 1, nothing happens. You have not actually changed the value of the number. So 5 times 1 is 5. 5 times 4 is 20. To change 5 into 20, what we're going to need to do is multiply by 4. Because 5 times 4 is 20. What we do to the bottom, we got to do to the top to keep it balanced, to keep it the same, to keep it equivalent. And notice 4 over 4 is 1, so that's really what we're doing. 3 times 4 is 12. 5 times 4 is 20. Now that we have the same number of pieces, we have 5 here, 12 there, so we just add the 2 together, 5 plus 12. The 20ths stay 20ths. We don't add them to get 40ths. That would not be appropriate. That means we would have divided it into more pieces. 5 times 12 is 17 over 20. We would reduce it if it can, but it can't. So we see it's right here. So that's our adding of fractions problem. Let's look at question 8. Again, looks like we're going to have to make a few fractions here. 12/5 of a mile, 6/5 of a mile, 5/6, 7/5. So a lot of these problems as we're going through is just a matter of deciding what are you doing, adding, subtracting, multiplying, or dividing. So understanding when we do each of them. So Sarah lives 12/5 of a mile from work. She stops at a coffee house on the way that is 6/5 of a mile from her home. How far is the coffee house from work? So again, here's home. She's going to work, but here's a coffee house. Coffee cup. That's where she stops, and then she's got to go the rest of the way to work. Building. Okay, so we're told that the total distance from home to work is 12/5, and that from home to the coffee shop is 6/5. So how much is it from the coffee shop to work? Well, if we just subtract, so this is taking 12/5 minus what she already went. And they were nice to us this time because they gave us common denominator. We don't have to get that, so it's just 12 minus 6, which is still 6/5. So this side here also is 6/5 of a mile. Six-fifths of a mile. Option C, right there. But notice on this one, the picture helped us to see that this was just a subtraction problem. If these were whole numbers, we would have just been subtracting whole numbers. Very good. About halfway through, a little more than halfway, right? Because we only got 15 and we already got 8 down. So here's a pizza problem. Go ahead and draw in my fraction bars. If I forget, remember they're there when you see two numbers, one number above the other. So Drew ate 2/3 of a pizza that was cut into 18 equal slices. How many slices of pizza did Drew eat? So again, the question is, we've got a pizza. It's already cut into 18 equal slices. That's a lot to kind of try and draw, but there's half. Let's see, we'll cut each of the halves into thirds. Sort of. I think that's eighths, aren't those? And then, so we got 18 pieces in here. What we want to sort of do is we want to change it from talking about how many 18ths we have into how many thirds we have. So we're just kind of looking how many would be in 2/3 of the pizza. So this really breaks down into being a multiplication problem. How many 18 of the 18 pieces would be contained in a third, and then we multiply it by 2. So we're dividing the 18 into 3 groups. This is the way to think of this. And then we're getting 2 of those groups. So we can do this by, you could take 18 times 2 and then reduce it, or you can notice that 3 goes into 18 6 times. And then 6 times 2 gives us 12 slices. So another of the key words here, of a pizza, 2/3 of. Of is a math word that means to multiply. So we want to take 2/3 times the 18 slices. Okay. That was 9. Let's get to 10. Let's see. Yeah, we do need some fractions in here. So this is 7/9 and this is 7/9. Oh, I forgot to fix this. This 7 should be 14. It refers to the the tree over there, 14 feet. Okay. So how many pieces of firewood can she cut of length 7/9 foot from the 14-foot tree? So what you have to recognize here is we've got our 14-foot tree, and what are we going to do? We're going to cut it into pieces that's not a foot long, but that are 7/9 of a foot. So we're dividing this 14-foot tree, this 14-foot piece of lumber, into 7/9 of foot-sized pieces. Dividing is the key word here. So we're taking 14 and dividing it into 7/9 of a foot pieces. When we divide with fractions, we flip the second part. So the way to carry it out is to turn it to multiplication and flip the second fraction, 9/7. Then as we do this, again, one of the ways to do it is before multiplying 14 times 9 and then divide by 7, you might see that 7 can go into 14 2 times. 7 goes into itself once. 2 times 9 is 18. 1 times 1 is 1. 18 over 1 is 18 pieces. Okay, so that's how I would approach this one. Again, there are problems in the homework and in the review. There's other videos. The 45 question review has something like this, so take a look at those and make sure you understand how to do a similar type problem. So that was 10. 5 more to go. Here's 11, and this will probably be the easier part of the test because it's now into decimals. Decimals, we can definitely use our calculators much more, although you could use the calculators in the other one if you have the TI-30. Okay, see no fractions in this one, so let's go with the green. So again, we look for the question, how many miles did he have left to bike on the third day? So he went on a 3-day bike riding trip. Total is going to be 150 miles. We know how much he did the first day. We know how much he did the second day. So what's left on the third day? So again, we know that we have 150 total miles from start to end. First day was 29.9. Then he went 34.9. So the question is, how much is left for the third part? So we could add these two together. Carry the 1, 4, carry the 1, 5, 6. 64.8 miles the first day. And then to find the missing part, we're going to have to subtract that from 150. So 150 minus 64.8. While we're at it, we got a nice little calculator sitting here, so let's just go use it. 150 minus 64.8, 85.2. And that matches one of our answers, which is good. Again, just knowing this involved both an addition and a subtraction problem. Okay. Here's 12. So what is her current altitude relative to sea level? So she camped at negative 5.6 meters relative to sea level. So she was below sea level. The negative is important. So if here is sea level, say she's down in a whole area, so we know that she is 5.6 meters below, and then later she's going to walk up to a place That is 17.1 meters from where she started. So we notice it can't be 17.1 meters above. Certainly couldn't be 22.7. We started at negative 5.6, so that doesn't make any sense. Could be either of these, but what it is it's a subtraction problem. It's 17.1 minus 5.6. I think you'll see just even judging it, it's got to be this one. But to be absolutely sure, maybe put it in your calculator. You never know, it might be closer. Yeah, 11.5 meters. That's above sea level. That's where she's currently at. Okay, so this is a distance here, not a amount above sea level. So she's now at 11.5 meters above sea level. Okay, 3 more. Almost there. And then again, then it's your turn to review anything you had some difficulties on, and you'll be ready for Wednesday. Okay. How much money does he have left over? Okay, so Scott makes $11.35 an hour for his part-time job. This is after taxes. Last week he worked 11.5 hours. So we take the amount he makes per hour times the number of hours. That gives us his total income. Okay. When he cashed his check, he bought 4 cases of soda. So what he's going to do is $3.99 times 4. That was how much the soda costs. And then what we're going to do is we're going to take this number, subtract off the soda, and that will give what he has left. Which one does he have left over? $11.35 times 11.5 gives us $130.53. We'll round it up. You don't have to worry too much about rounding because being multiple choice, there's not 2 answers that are too close to each other. So that's 130.53. $3.99 times 4. Let me see, well, that's close to 12. That should be, what, 11.96? But let's just do it. 3.99 times 4. 15. Oh, it's like 4 times. See, that's why you use the calculator. Sometimes you took 3 times 4 and got 12, but I should have took 4 times 4 and got 16 and then subtract the 4. So 15.96. And we subtract these two, and that'll give us, so it's less than the 1/5. This is what he made, so that's not correct. These two look good. It's certainly $15.96. That's what the soda costs. That's not correct. It's one of these two, and it's a rough guess. I think it's going to be this one. But again, let's make sure. Let's not just take a guess, because those are the two that are designed to be close to each other. It just takes a moment of time to be absolutely positive that yes, it is correct. B is how much is left. 2 more. Countdown to success. Remember, as you know how to do each of these, you'll do just fine. So Roberto is running a science experiment. If he decreases the temperature of a liquid by 24.8 degrees in 4 minutes, what is the change in temperature per minute? Seems like one we had before. So we want it per each minute. So again, we're going to drop at this total over 4 minutes. So the per minute, it's a division problem. So we take 24.8 divided by 4. And it's going to be negative because it's a drop, so each of these has a negative. But we can see it's going to make this number smaller, so you could say, that's ridiculous. This is ridiculous. And this is the total amount. That's too big. Hey, we don't really even have to do the calculation if we understand what's going on here, but let's do it, and that'll make us feel maybe more confident. 24.8 divided by 4 gives us 6.2. Perfect. But oftentimes with multiple choice, you can do it by the process of elimination, finding out the wrong answers. Okay, last one. Let's take a look at 15 and then we'll be ready. But again, keep on reviewing. Go over those 14 questions. You really want to study this way beyond the test. I'd like you to come in and find that the test is not an issue at all, because this content is stuff you're going to use throughout your life in situations, and more important situations than getting it right or wrong on a test. It could affect how much money you have in your pocket, and those kind of things, your job. So George ordered 4 items online, and he's charged $1.95 per pound for shipping. And then we're given a list. The items weigh 2.7, 1.1, 3.6, and 1.3 pounds. How much will he be charged for shipping? So we have to add all of these together and then multiply. Now you could do an estimate. This is about $2. So you could just do a quick 2, 5, 6, 7, 8, maybe about 9 pounds. 9 times 2 is 18. I'm going to take a real strong guess. It's got to be like this one, just with an estimate, right? This is way too small. This would only be about 2.5 pounds. So that's like for the first one, maybe. This is way too much, and even 31 seems like a lot. So, but let's do this. It's really just 2.7. See, that's what the dyslexia does to you. You just write down, you say something, but you write something different. And then that's where you make mistakes, but you can recover and just slow down, right? I have to do it. If you need to do it, do it. Just find your pace. You don't always have to be fast. That's one of the things. I let people rush me, and I shouldn't. I need to just calm down a lot of times, be mindful, slow down and say, hey, we'll get it when we get it, right? 2.7 plus 1.1 plus 3.6 plus 1.3, so a total of 8.7. So I was pretty good with my estimate. I figured around 9. And then we want to take that total weight. This is pounds. Multiply it by price per pound. So we multiply by 1.95. And again, there's no real advantage. You could do this by hand, but it's tedious, time consuming, and from my perspective, error prone. I can usually more easily see I have entered it correctly into the calculator, 1.95. But again, the estimating is 2 times that, about, 16.96, round up 97, that's exactly right. You just want to be able to make sure in a line that when you get charged that you're getting charged the right amount. And if they come up with 31.22, I think they doubled it or something. But it's way off. It should only be about $17, maybe $18 at the most. Okay, so those are our 15 questions that we're going to ask you to take a look at tomorrow. Not tomorrow, Wednesday, this coming thing, and then you'll get a little bit of a spring break and time to relax. So keep moving forward, keep studying, prepare yourself. contact me if you have questions. I'd be happy to help you. I've got office hours. I can contact you. I can send you specialized videos. Whatever you need, get a hold of me. We'll make your success happen. Thanks, and we'll see you Wednesday.